Good afternoon, everyone, and welcome back to another Tech Talk Tuesday here at Treadwell. Edward Titley is my name. If you're joining us for the first time, welcome. And if you've been to previous sessions, welcome back. Really appreciate you coming along to these sessions, and we do hope you find value and find the content we discuss interesting. Firstly, we have another poll in today's session. If you can see that on your screen, so please answer it. The good, bad, and the ugly. Honest feedback is great. We'd like to know what you'd like us to cover in the future. We'd like you to comment on how you find these sessions, whether they're providing value or providing interesting content to you. If they're not, please say so. As I said, good, bad, and the ugly. Any feedback is good feedback, and we want to make sure you're all getting good value out of these sessions. Today, we're continuing on our discussions around the ACMA, or the American Composite Manufacturers Association standards. Specifically the LFRD standard for the design of pultruded composite structures. Now, before we get started, a bit of the usual housekeeping. Obviously, firstly, I'm not the ACMA, so I can't comment on what they were meaning when they wrote a standard or read into the standard at all. Secondly, as we all know, standards are subject to interpretation, so I might interpret the standard differently to you. And thirdly, therefore, this is general advice or a general commentary. And if you're looking for site or project specific advice, please reach out to us directly. And lastly, as always, we've got the Q&A window open in front of me right now. So please feel free to pop any questions in as you think of them. We'll answer them today if we can. I've also got Hardik on board, who's one of our structural engineers. So between us, we'll hope to be able to answer any questions you might have. And if we can't, then we'll take the question on notice and get back to you. So with that said, let's get into it. We're looking at Chapter 8 of the ACMA today, bolted connections. Now, I realise that these 15-minute webinars are probably not a lot of time to delve very deep into the standards that we look at. I'm conscious of that, but also conscious of your time, so I don't want to make it longer than necessary. So what we're going to be doing today is just having, once again, a bit of a look at simply at the content that's contained within the standard. So I'm not going to sit here and read the standard to you. I'm just going to draw your attention to some pertinent points. I'm not going to run through in detail the formulas and the reasonings and so on contained in the standard, but just simply to draw your attention to some of the content that's in there, with a hope that perhaps those watching and those listening will be interested enough to have a look at the standard themselves in more detail, with the view of being more familiar or more comfortable with the design of composite structures and the use of pultruded structural members in their projects. So, as we mentioned last week, the ACMA standard is intended to be used for the design of new buildings and other structures constructed with pultruded glass fiber reinforced polymer, or FRP, composite structural shapes. And as I said today, we're just having a quick look at Chapter 8 around connections. We selected Chapter 8 because a lot of the questions we get asked are around connections, and I think perhaps if we draw those listings' attention to what's in the standard, a lot of these questions would be able to be resolved, and everyone would be able to feel a lot more comfortable with the use of structures. So Chapter 8 outlines design provisions for bearing type bolted connections in FRP structures, including material specifications, allowable connection types, testing requirements and limitations, etc., and all obviously subject to compliance to ANSI or AISC standards and the outline constraints. So just a bit of basics before we go any further. With FRP, the majority of our connections are bolted. We don't have the ability to weld the product like we can with traditional materials such as, say, steel or stainless steel or aluminium. We're not looking at adhesive connections at all. The content of this chapter purely considers a bolted only connection, and that's I bring that up because that was I had that question last week in my travels, as far as whether we're also considering adhesives in conjunction with bolting. So just to be clear, this chapter is considering mechanical connections only or bolted connections only. Now, what's excluded in this chapter? The chapter excludes bolted connections with more than 3 bolts in a line, parallel to the connection force direction, We'll have a look at a diagram in a minute. Hopefully that'll help things make a bit more sense than me talking at you. Also excludes configurations with 3 or more bolts in a line perpendicular to the force. Complex configurations require testing or analysis for justification. Double row joints may be used for stability against compressive loads, and as we've mentioned, adhesive bonding is not required in these bearing type connections we're looking at today. In regards to the bolts or the fixings, the standard makes several provisions around the fixings that are used. Firstly, bolts made of carbon or stainless steel must adhere to the ASTM standards A307, A325, or F593. Bolt diameters considered as part of the standard range from 3/8 of an inch, 9.5 mil, up to 1 inch, 25.4 mil. So really, for what we'd use here, we'd be looking at bolts in the range of M10 through to M24, M25, as part of the scope or the detail provided in this standard. Also deal with something now while I think of it in regards to FRP fixing. So as we know, or as you probably know, the majority of structures we do here at Treadwell have metallic fasteners, typically 316 stainless, sometimes more exotic things like duplex or super duplex. And we have also discussed titanium fasteners in some instances. Now, FRP fixings are available. We will carry some in stock, and we use some products, specifically our cable ladder and those sort of things. Now, the limitation with an FRP fixing is that to achieve the required strength in that fixing, we're typically looking at a reasonable upsize in the size of the fixing from what we'd be looking at if we use a traditional metallic fixing. So, and this is just by way of comparison. This is by no means a reliable rule of thumb, but just hypothetically, if we were using an M16 stainless bolt, we may need to go to an M20 or perhaps M22, M24 FRP fixing. Now, on the next couple of slides, we've got a diagram around fixings from the ACMA, and as you'll appreciate when you look at that, the limitation will become the physical real estate, if I can use that term, in the connection. As in, we're not able to get the edge distances and those sort of things we need if we go to a larger fixing. So whilst it can be done, and we have done structures using all FRP fixings, oftentimes it's not necessary or not practical to do those. But if we're in an area of extremely high corrosion where a metallic fixing is just not going to be suitable and not going to be durable, then it is a path we can go down. I just thought to bring that up at this point. Now, size of bolt holes. Another thing we often get asked. Nominal hole diameter, being DN, should exceed nominal bolt diameter by 1/16 of an inch or 1.6 mil, as we discuss over here. Holes must be either drilled or reamed, so we wouldn't recommend the punching of holes in the FRP products. Experience dictates that doesn't produce or can produce some damage around the hole by the use of a punch, and therefore we'd recommend drilling or reaming as the primary methods of making those holes. Also suggest that you avoid oversized holes exceeding 1.6 mil larger than the bolt diameter, and also ensuring that slotted holes are not aligned with the primary direction of connection force. That refers back to section 2.9 of the ACMA, which provides minimal design requirements supplemental to Chapter 8 on bolted connections. So that would be worth having a look at section 2.9 also in the standard. And I should add, if you'd like a copy of the standard, just drop us an email. We'll give you an email address at the end of this discussion. We'd be happy to show you where you can download that. And as I said, I would strongly recommend everyone that's interested in learning more about FRP structures and how the FRP products behave when they're using the structure to have a look at that standard. And I'd hope that you find what's contained in there interesting and worthwhile. But I would draw your attention, as we're doing today, to Chapter 8 around bolted connections. It's often where we see people being uncomfortable or potential challenges. Now, nuts and washers, it's obviously also part of a bolted connection, compliant with the ASTM standards, as we mentioned before. So the A563 standard for A307 or A325 bolts, and for F593 bolts, the standard F594 is applicable. Once again, washers, matching bolt and nut grades, that's pretty straightforward. And then the use of washers. Now, we would recommend the use of washers on both sides of the connection, so under the head of the bolt and under the nut. And the outer diameter of the washer is suggested to be at least twice the bolt diameter, and thickness ideally minimum 4 mil. One required at bolt head and washer required at nut, as we've mentioned. And lock wash is optional. Our advice on that is the use of nylock nuts or some other lock nut or a thread locking compound is a better solution than the use of a lock washer or spring washer, but there's no issue with using those if that's your preference. However, our recommendation would be using a lock nut on all bolted connections. And that's how we'd supply a standard unless requested otherwise. Now, connection geometry requirements. As I said, look, I'm really not sure we can do this justice in today's webinar, but as I said, I'm just really hoping to draw your attention to the content of the standard rather than provide a full summary of what the standard contains. So with that in view, this is figure 8.1 that you'll see in the standard. It gives us the connection geometry requirements based on the direction of the pultrusion, as we can see here. So that's also something important to note. We'll be familiar with the direction of the pultrusion. We can clarify that around any of our products if you need it clarified, just to make sure that we're using the section in the correct, shall I say, orientation to work with this standard. Now, maximum bolt spacing is 12 times the minimum thickness of the material, up to 3 rows of 3 bolts allowed with consistent specifications. I think this is probably fairly straightforward, really. And then table 8.1. Sorry, I didn't have room to fit them on the same slide, but I'll just talk through this briefly in the light of this diagram we've just seen. As I said, would suggest you have a look at the standard yourself to become familiar with this. But edge distance, considering a single row of bolts, is suggested to be 4D, where D is the nominal diameter of the bolt, and 2 or 3 rows, the end distance is considered to be 2D. That's tension load, and then compression load edge distance, or end distance, I should say, for all connections at 2D. Edge distance to be 1.5D. Once again, D is the nominal diameter of the bolt. Pitch spacing being 4D. And then we'll note, once again, we refer to C, where the pitch distance, pitch spacing, or S-min, cannot be met. The connection strength is reduced according to the geometry factor C delta in section 8.3.1.1. So once again, worth having a look at that. Gauge spacing 4D, gauge spacing with staggered bolts at 2D, and then the staggered distance of the bolts at 2.8D. As I said, sorry, that's probably not particularly clear without having this immediately beside the table, but I'm afraid due to logistics, I couldn't make that happen. But as I said, happy to send the standard through to you in due course. Design strength or design of connections, probably don't need to explain this, but I'll just touch on it. The strength of a bolted connection is obviously determined on the basic strength of the basic strength of its basic components, nominal strength of single, 2, 3 rows of bolted connections we've discussed, and then tension and shear strength of the bolts frame connections. Here's an example of an FRP structure. We can see numerous bolted connections here. And then lastly, I would have thought standard one as well, but we'll just touch on it. Column bases and bearing on concrete, proper provision shall be made to transfer the column forces and moment to footings and foundations. That would be the same as I would have assumed with any other structure. So that's the end of our session. As I said, I'm sorry, I realise we can't really do justice to each of these chapters with one session, but conscious of your time, so just seek to draw your attention to the contents, with a view that hopefully if you're interested, you'll be interested to pursue it further. Thanks again for joining. Please drop us a note, hello@treadwellgroup.com.au, if you'd like to have a look at the standard. We can send you a link to download a copy, or give us a call 1-800-246-800 for Australia and 0800-244-600 for New Zealand. 1:46 p.m. here in New South Wales. So please feel free to, we'll stay on board for a minute or two, drop any questions you might have in the Q&A window, and as I said, we'll endeavour to answer them here if we can, and if not, then we'll might have to take the question on notice. But any questions, please drop them. We'll stay online for a couple of minutes. And if I bored you all to tears, please put that on the Q&A chat as well, and we'll try and make it a bit more lively next time. Got a question in regards to fire resistance. Look, good question, and I'm going to give you a fairly roundabout answer because I don't know the project you're working on or the requirements of the project, but there's various additives that can be added, can be incorporated into the resin mixture or for the FRP, so the polymer part of the product, and they would dictate its performance around heat resistance or performance in the event of a fire. So depending on the project requirements, different resins and different additives would provide required fire resistance. However, I need to mention FRP products do not have an FRL in the sense or in the same way that a traditional structure for a building would have. So a length of time and a temperature rating. FRP products are typically tested according to AS 1530 Part 3. I'm sorry, I can't remember the name of that standard, but you could look it up. We're happy to discuss further offline. Typically AS 1530 Part 3 or C1.10 of the NCC, or International ASTM Standards E84 is one of the common ones. So I'm sorry you're getting a reasonably roundabout answer, but without knowing your application and your requirements, I probably can't really give you a direct answer other than to say that all our products incorporate a fire retardant additive. Test reports available on request, and happy to discuss on a project by project basis. If you drop us a line, hello@treadwellgroup.com.au, be happy to take up that discussion further. But the short answer is we get those characteristics through the use of or the incorporation of various additives. In regards to a tightening method, the method considered in the ACMA is simply snug tight, being mindful that would rely on the use of anti-crush inserts in bolted square and rectangular hollow members. Otherwise, if you're not looking to use if you'd rather go away from an anti-crush insert, then we can look to do a torque spec, but experience has shown us that doesn't typically get adhered to on site, and therefore snug tight is the method that we would suggest, and the method that the ACMA considers. Last question in regards to kick plates, I can answer that verbally if you like. Kick plates to connect to floor mesh, yes, they are available for our grating product. and they're also available to be mounted on a handrail. So two methods of kick plates, yes, both those are available. That looks to be all the questions. I'll just stay on. It's 1:51 p.m. here in New South Wales. Stay on for another half minute or so if you think of anything else. Otherwise, thanks again for joining. See you again in 2 weeks, and we look forward to having a look at the results of the poll that hopefully you've been able to complete today, with the view of providing more relevant content. And we always welcome any feedback, positive or negative. As I said, if you find these discussions worthwhile, good. We'd like to hear that. And if you don't find these discussions worthwhile, well, we're interested in hearing that too. So thanks very much, all. Appreciate you joining, and we'll wrap it up now. See you again in 2 weeks for another Treadwell Tech Talk Tuesday. Cheers.